Good afternoon, everyone. I'm Steve Lumley. I'm the Communications and Education Program Manager for the Joint Office of Energy and Transportation. We are going to jump right in things today because we've got a packed program and a very exciting update on J3400 and the state of the market. So we'll go ahead and get going, but want to welcome you all to the webinar today. If you could advance to the next slide, please. So just a few tips and a disclaimer before we get started. The controls are located at the bottom of your screen. If they aren't appearing, you can move your cursor to the bottom edge. And we do encourage you to submit questions using the Q&A window rather than the chat window. We have a few questions that were submitted as people registered, and we'll be addressing those first. And then if we have time, we will take your questions in the Q&A session at the end. I do want to note that this webinar is being recorded. It will be posted on the Joint Office website. We also may use it internally. So if you do speak during the webinar or use video, you are presumed to consent to recording and use of your voice or image. Next slide, please. So here's our agenda for today's webinar. I'm going to do a quick introduction, and then we're going to ask you a couple of poll questions, and then we get to hear from our Executive Director of the Joint Office, Gabe Klein, and then some updates from the Federal Highway Administration on updates to the frequently asked questions for the program, the NEVI and CFI programs. And then we've got presentations from a great slate of panelists, and I'll introduce those here in a minute. And then, as I mentioned, we'll have some discussion and audience Q&A at the end. Next slide, please. All right, want to start out with a few quick polling questions just to get a sense of our audience today. If you could pull those up, we'll give everyone a chance to respond to those. So first question, what sector do you represent? Always helpful to understand if you're coming from government or industry, academia, nonprofits, that sort of thing. So I'll just give everyone a minute here to respond, and then we'll take a look at the results. All right, I know we've still got people trickling in, but looks like we've got some great representation here from local regional governments, state governments as well, federal partners, and then folks from the non-governmental sector, utility and EV industry. So really great to have you with us today. We'll advance to the next polling question, please. Again, just getting a sense of where everyone's from. Looks like we've got lots of folks from the Northeast as well as the rest of the country. So this is super helpful. All right, I think we got a critical mass in attendance now, so we can go ahead and close out this poll and move on to our next slide, please. All right, so now I'm going to turn it over to our Executive Director, Gabe Klein, who's going to make a few introductory remarks. Gabe, so happy to have you with us today. Why don't you take it away?
All right, thank you, Steve, and thanks for everybody that signed up and that is joining us today. I think many of you or most of you know about the Joint Office and our mission to accelerate an electrified transportation system that's affordable, convenient, reliable, safe, and where anybody in the United States can choose to ride and drive electric. Next slide. And many of you also know our work from our technical assistance efforts across all levels of government. But I think it's always helpful to remind folks what we were asked to do by Congress in the Infrastructure Investment and Jobs Act. And so this is just a summary of the statutory language. Many people of late have asked us what's next for the Joint Office. Obviously, there's a change in administration coming. So I think it's important to let people know this is the summary. We're written into the IIJA. And of course, Congress can always change a bill, but this is currently what we are legislated to do. And you'll see number 9 says, in addition to the core 8 areas of emphasis, which by the way are all underway, we don't get to talk about all of that every day, but you'll hear more in the upcoming months and years. But any other additional issues of joint interest from the Secretaries of DOT and DOE. Next slide. Within the government and typically through the private sector, the Joint Office supports several programs that were established in law. And it's actually over $19 billion in IIJA funding for clean transportation. I'm not going to go into each one, but you can see there's a range, and actually is also across EPA as well as DOT, Federal Highways, FTA, and DOE. And then, of course, we have our own funding as well. We'll be making some announcements in the coming weeks along those lines. Next slide, please. What really, and I just added this in today, but what people often don't know is that the Joint Office also supports the private sector in numerous ways. And I think today's webinar is a great example of that. Often we do that in partnership with the national labs or foundations like Linux or NGOs. And today we'll be talking about our work with SAE. And we foster the alignment of public and private around solutions like J3400 or open source via Everest, which I just mentioned, enhancing interoperability on a regular basis. Sometimes government needs to lead, sometimes enable, and sometimes just support the private sector as it leads. But it is important to note that the Joint Office is a groundbreaking effort to remove red tape, to streamline and improve industry to government partnerships, and to foster innovation as fast as humanly possible on behalf of the American people. Next slide. We've also learned a lot since we were formed. So there's some proactive issues that we knew we needed to address, and there are issues that have risen to the top. When we started the Joint Office, the open sourcing of NACS, and then the reaction from us and the federal government to then write NACS and now J3400 into the minimum standards was not something that we expected. And I think any solid organization is ready to react to whatever's happening in the market and to work with the market. And so we're working on a daily basis with many of you on this webinar, even as guests, to improve, solve, or set the stage for the future of charging and sustainable fuels. Next slide. However, there's a lot to celebrate, not just problems to deal with. And through myriad combinations of federal, state, local funding, and of course, considerable private sector funding, the national network has doubled since the Joint Office has come into being. We're over 205,000 charging ports as of this week, and there's almost 25,000 federally funded ports underway, which I think is very notable. Next slide. And we've got 259 just completely federally funded charging ports with private or state match across 15 states. And charging progress is accelerating, as I said, with almost 25,000 ports underway. And per the federal minimum standards and what the market is demanding, they're opening with J3400 and CCS connectors to assist the maximum number of people in charging their vehicles. Next slide. But we do need to remember, most charging is not fast charging, and J3400 will address both. So, most charging will still happen within communities at home and work. And just a reminder that the 2030 National Charging Report from NREL finds that 85% of the needed 1.2 million public charging ports will be low power, level 2 charging. And the US is on track to meet this target. But as I was saying, J3400 matters here too. Being able to support home, destination, curbside AC charging for all types of vehicles is important to grow the charging network and grow consumer confidence in EV adoption. So in this webinar, we're going to learn about how a new standard is changing the face of charging, including affecting EV model availability, charging locations, the charging experience, and potential for smarter energy use. But let's first hear from our compatriots and partners and collaborators at the Federal Highway Administration about NEVI program updates related to J3400. So I'm going to turn it over to my esteemed colleague, Soraya Motzinger. Over to you, Soraya.
Thanks so much, Gabe. And let me go ahead and share my screen real quick. There we go. And yeah, thanks again, Gabe. And thank you to the Joint Office for arranging this panel of industry experts who we're going to hear from today for their insight into the market evolution of J3400. As Gabe mentioned, my name is Soraya Motzinger, and along with my colleague Will Stein, who you'll be hearing from in just a moment, we work for the Federal Highway Administration's Office of Natural Environment, where we lead up the NEVI program on behalf of the FHWA's program office. And as we kick off the conversation on the J3400 connector today, we wanted to remind everyone that when using federal aid funds, the connector type of an EV charging station is regulated by 23 CFR 680 106C. And if you're at 23 CFR 680, you can navigate to it pretty easily. And this shows what the connector type regulation currently is. Now, we are continually monitoring industry advancements, and thanks to the help of our colleagues at the Joint Office, here at FHWA, we've been keeping abreast of the conversation in the industry regarding the adoption of J3400. And to find out more information, we issued an RFI on this technology just this past March. And that RFI closed on April 5th, 2024. And the information that we received from the RFI is currently being considered by the Federal Highway Administration, along with additional information that we've received through other RFIs and in coordination with the Joint Office. But it's really important to emphasize, I know there's been some misinformation out there, that right now the standard for connector types for federally funded EV chargers is as you see on screen. And I'll turn it over to my colleague, Will.
Yeah, thanks, Soraya. Next, we're going to highlight some new NEVI questions and answers that were released just last week and added to FHWA's website, which we've just pulled up here. And we'll briefly go over the ones specific to connectors and the J3400. The first is question 1.2, and this was revised to further clarify that NEVI funds can be used to purchase adapters. And this answer note items 1 through 4, which include clarifications that adapters must be permanently attached, fully integrated into the charger, and approved by the charger manufacturer. And also chargers with adapters must also comply with all sections of 23 CFR 680, which Soraya just showed previously. The next one, question 1.3, was added to clarify that NEVI and other Title 23 funding programs where EV charging infrastructure is eligible may be used to purchase J3400 connectors and supporting equipment. Note that the CCS connector is required on DC fast chargers, and the J1772 connector is required on AC level 2 chargers. But in addition to those required connectors, the regulation does allow for permanently attached non-proprietary connectors, including the J3400. Question 1.4 added information on the current status of the process to finalize the J3400 standard. 3 significant milestones are indicated here as shown, and the most recent of those was in September of this year. Question 1.5 provides information related to the request for information on the J3400 connector, which Soraya just mentioned. All of the submitted comments are publicly available and can be viewed at the link provided here in this answer. And I just want to mention, in addition to these questions specific to connectors, there were a number of other Q&A added, and they're indicated with the yellow tags here as shown. So I'd encourage folks to take a look at those others as well. You can kind of scroll through and find those easily. And with that, I'd like to thank you again for attending today, and I'll hand it back to the Joint Office.
Great. Thanks so much, Will and Soraya, and Gabe too, for that wonderful context setting. Now we're going to move into the panel portion of our presentations today. So we're going to start out with Sarah Heipel. She's the Acting Chief Technology Officer here at the Joint Office, where she leads innovation and strategy to advance electric and connected mobility infrastructure. Sarah has extensive experience in the electric and connected vehicle fields with strong technical proficiency and high voltage charging, commercial vehicle design, and advanced security control strategies. And then we'll get to hear from Frank Menchaca. He's a president of Sustainable Mobility Solutions at SAE, which is a startup that discovers, incubates, and develops products, programs, and services that help the mobility industry achieve net zero emissions. Frank has over 25 years of experience and is passionate about creating and delivering value for customers, partners, and stakeholders in the aerospace, automotive, and other mobility sectors, and he played a major role in J3400 standardization. And then we'll hear from Sam Abou-Samid. He's a principal research analyst at Guidehouse Insights, which is formerly Navigant Research. And he develops and writes a syndicated and custom research reports with a focus on alternative fuels and powertrains, advanced driving technologies, and connected fuels. And his background in automotive engineering gives him an insider's perspective on vehicle technology development. He's also the author of Recharging the Car, chronicling the development of the 2011 Chevrolet Bolt. And then Joanne Zhao is a group manager for mobility and deployment at Argonne National Laboratory, and she assesses energy and emissions impacts of advanced vehicle and fuel mobility technologies. And she's particularly interested in vehicle technologies, alternative fuels, freight modes, mobility trends, and behaviors. And then Abby Brown, a project leader at the National Renewable Energy Lab, specializes in alternative fuels and advanced electric vehicle charging equipment. And she's going to talk to us about the work that she does in leading the DOE's Alternative Fuels Data Center Station Locator, which includes collaborating with states and communities and charging providers and other partners and stakeholders on station data collection and related efforts. So with that, we'll move to Sarah. And Sarah, take us away.
Next slide, please. Good afternoon, everyone. Thank you for joining our webinar to discuss the pivotal role technology plays in shaping policy. We find ourselves in an era where innovation is reshaping industrial priorities. Today, I'd like to focus on how these advancements are driving critical progress in building technology locally, enhancing the resiliency of our utility grid, and safeguarding our nation's infrastructure through robust cybersecurity measures. Let's begin with the transformative role that stabilizing and simplifying standards plays in shaping the future of manufacturing and the connected electrified infrastructure that underpins it. In a rapidly evolving global market, ensuring the United States remains a leader requires more than just innovation. It requires consistency. Stable, simplified standards provides the foundation for seamless integration of advanced technology, reducing fragmentation and creating a more efficient path to progress. Consider the significance of a standard like SAE J3400, which streamlines charging compatibility across all vehicles. By simplifying charging protocols and ensuring interoperability, this standard reduces the complexity of integrating diverse vehicles, chargers, and grid systems. It not only accelerates the deployment, but it also builds confidence across stakeholders, from manufacturers to consumers. Stabilizing such standards fosters predictability, reduces costs, and ensures that U.S. industries remain agile and globally competitive. Simplified standards also are critical to scaling infrastructure efficiently. Without them, fragmentation can lead to delays, inefficiency, and wasted resources. A unified approach supports a seamless evolution of technology and engineering in tandem with electrified infrastructure, enabling real-time communication and integration between vehicle charging networks and the grid. What you see here is the network, or the ecosystem we currently have, which shows the proliferation of various standards. I won't go into detail on the standards in the box on the left, but they cover connector standards, which we're focused on today, from the separate standards that we've historically had for AC charging and DC charging, to now what we'll cover megawatt charging and bring your own cable charging standards. As we move forward into the future of connected electrified infrastructure systems, we have the opportunity to begin consolidating on simpler, more streamlined standard processes as we've seen in other systems in the past, such as telecoms and other communication systems. As we begin prioritizing and stabilizing a simplified standard system, we can create a framework that aligns all stakeholders and shared goals. Next slide, please. Automotive advancements are also reshaping the broader energy ecosystem, highlighting the importance of grid resiliency. Today's vehicles interact with the grid in ways that were unimaginable a decade ago. Managed charging technologies such as V1G offers opportunities to align vehicle charging with grid demands, reducing strain during peak hours and enhancing overall system reliability. Through initiatives like ChargeX and EVs at Scale, we are tackling key challenges in scaling and integrating these systems into existing infrastructure. These efforts are essential not only for maintaining reliable energy delivery, but also for supporting national competitiveness by ensuring a secure and modern grid that can adapt to evolving demands. Having streamlined standards such as J3400 standard allows us to begin working shoulder to shoulder with the private sector and public sector engineering to begin relaying communication standards like those in the ISO 15118-220 and now 200 series over a single connector, which can help us drive toward common solutions in V1G and V2G applications. Next slide, please. As our transportation and energy sectors become increasingly interconnected, cybersecurity has emerged as one of the most pressing challenges we face. Every point of connection in our automotive and energy systems presents a potential vulnerability. Protecting these systems is not just a technical necessity, it is a national security imperative. The Joint Office of Energy and Transportation is actively working to ensure that cybersecurity is built into the foundation of these advancements. Collaborating with experts across the public and private sector, we're developing robust guidelines and technical assistance to protect both data and infrastructure. Our partnerships with SAE, as well as offices within the National Cyber Director and participating in action plans across cross-sector collaborations is essential for this effort. We know that J3400 as a connector standard between the vehicle and the charging infrastructure is a key to a communication point within the private and public sector ecosystems to foster conversations around touch points for cyber and cyber physical security. We recently discussed in a plug-in charge webinar and conversation around the release of a enabling technology also through the Society of Automotive Engineers, that these technologies can come together now to have cyber and cyber physical secure solutions for charging and infrastructure connectivity that we can begin leveraging for greater connected infrastructure. In conclusion, the intersection of automotive innovation, grid resiliency, and cybersecurity requires a unique opportunity for the United States to lead on a global stage. The work we are doing at the Joint Office of Energy and Transportation is more than just advancing technologies. It's about strengthening American competitiveness, ensuring our infrastructure can withstand future challenges, and protecting our nation's critical systems, while giving people the choice of whatever transportation best suits their needs. But we cannot do this alone. Your engagement is essential. Whether you're a policymaker, an industry leader, a researcher, your contributions are vital to shaping a resilient and competitive future. We thank you for joining us today, and I'll hand it over to Frank Menchaca.
Thanks, Sarah. So I'm Frank Menchaca. It's a pleasure to spend some time with you. Thank you for spending some time with us. I'm going to talk about how J3400 happened. I have to say up front that it took a village to do this standard in record-breaking time. And that really started at the instigation of Sarah and Gabe and the entire Joint Office team. And it has to be said also, this would not have happened without Christian Thiele's excellent leadership of the ground vehicle standards at SAE, and of course, Rodney McGee, who is the committee chair that made this all happen. So let me talk a little bit about how this happened, what its impact is, and really how it can help us think about standardization and policy and technology in a new way. So next slide. So bipartisan infrastructure law, national electric vehicle infrastructure really catalyzed the development of EV charging. Spent a lot of time out with customers, and we really got a sense for what the landscape was like prior to J3400. It was very fragmented. You had CHAdeMO, you had CCS1, you had NACS. So a very fragmented landscape existed before this standard came about. Then in the spring of 2023, there were several large manufacturers, Ford, GM, Mercedes, Stellantis, but lots of others, that announced that they were going to begin making NACS connected vehicles. This became a challenge, but like any great challenge, there's a great opportunity. With so many new chargers going into the ground, NACS really needed to be standardized to permit drivers to be able to use both Tesla and non-Tesla charging networks. And I have to say, this was really kind of a game-changing effort, because without J3400, you would have had still this very kind of siloed charging infrastructure. J3400 and the cooperation between SAE, the Joint Office, and industry really helped to change that. This had to be done quickly since new charging stations were going into the ground. We wanted them to be interoperable, and so Joint Office and SAE partnered to develop and write the standard quickly. So next slide. So what was different about that? So typically, a standard can take about 24 to 36 months to write. Most standards are written when the technology or approach to the technology are settled. So they kind of come from the grassroots up. When industry decides it's time to standardize something, they come to SAE, we put together a technical committee, and there's lots of debate to reach an industry consensus, and that takes a couple of years. What was different about this is that the technology and the delivery approach were still unfolding. To Gabe's comments at the beginning of this session, he talked about the fact that we're in a very dynamic environment. Even though we're in a dynamic environment, there still needs to be good work practice, still needs to be standardization. In fact, there needs to be maybe even a greater need for standardization, but we need to think about it differently. So why does that matter? So even though, or maybe precisely because things were unsettled, manufacturers needed guidance. Industry reached consensus quickly about what would be competitive and non-competitive. So one key aspect of standardization is that it really has to be pre-competitive. It needs to be industry coming together to decide they're not going to compete on something. And so I think everyone, all parties kind of recognized very quickly what impact this could have. And this enabled standardization and policy to kind of unfold together. So next slide. So this is really kind of a new model. What this standard helped to do, and I think Sarah's diagram did an excellent job of this, it helped to build a continuous digital communication between the vehicle, the charging station, the infrastructure, that was pointing toward using one connector or one major connector across an entire range of charging ecosystems, both Tesla and non-Tesla. And so everybody recognized how this was important. The way that this evolved was we started working iteratively. In an agile manner, we decided what is important for industry to reach an objective piece by piece versus all at once. And I think that really allowed us to create a very advanced time frame. So as I said, typically it takes about 24 to 36 months to do a standard. This was done in a little bit less than 12 months. Technical information report, which is the last iteration of it, was out in September, and we started about 9 months prior to that. Other examples I think to think about are important areas where technology is still evolving, like mineral traceability for batteries, carbon footprinting measurements, recycling. Not all standards need to be written this way, but I think J3400 did a tremendous good to the public infrastructure and the private infrastructure going in for charging. And it also, to Sarah's point, I think pointed to a new direction for thinking about how to evolve standardization and policy kind of hand in hand in an iterative manner, still settle the technology to a point where it can be worked on, but not try and do everything at once. So it was a great pleasure to be involved in this. As I said, it took a village, so hats off to the SAE team, to Rodney and the entire technical committee, and of course to the Joint Office. Thanks very much. And I will hand it off to Sam.
Thank you, Frank, and thanks to the organizers for inviting me to participate today. I'm going to talk a little bit about the current status of J3400 adoption in the U.S. market. So if you want to go to the next slide. So it's still obviously still very early in this process, particularly from an automotive perspective. You know, the auto industry does not typically move this fast. It's been less than 2 years, about 20 months or so since we got the first announcements of this. Actually, no, even less than that, about 18 months or so since Ford was the first to jump on the bandwagon and announce that they were going to make the shift to what is now J3400 and add support for superchargers. By February of this year, virtually every other OEM had followed suit, with Stellantis being one of the last ones early this year. And then at the end of February this year, about 9 months after making the initial announcement, Ford started pushing out an OTA update to their EVs that enabled support for superchargers with plug-and charge capability. And also taking orders for their J3400 to CCS adapters. And that was followed 2 weeks later by Rivian. And that's when things kind of started to stall out. Next slide, please. As is often the case, Elon Musk threw a speed bump into the whole process. In May of this year, he fired the entire 500-person supercharger team as part of a larger round of layoffs at Tesla. Many of them were later rehired. It's not clear how many are there now, but despite all of that, that has caused a lot of grief for other automakers that have been in the process of trying to deploy their software updates to their existing EVs in order to ensure the interoperability, the proper interoperability with the supercharger network. There's obviously a lot of validation work that has to go on when deploying these software updates, particularly for those that want to do plug and charge. Some OEMs like GM and Nissan have forgone adding plug and charge capability for the superchargers. That may be related to this. GM, for those manufacturers that have taken a pass on plug and charge for now, they are relying on customers to use the Tesla app to initiate and manage charging sessions. So that's a little bit less convenient than it has been for other, particularly for Ford and Rivian, who were first out of the gate. Next slide, please. As I mentioned, at the end of February, when Ford started rolling out their software update, they also started taking orders for customers to get their adapters, their J3400 to CCS adapters. The initial batch of adapters were all being manufactured by Tesla, and those started shipping to customers in June of this year. Those have since been joined by at least 2 third-party adapters that are out there that seem to be pretty good from Electron and A to Z. And in fact, the Electron adapter is also now being shipped by Ford as an alternative to the Tesla adapter. Tesla has had apparently some difficulties in actually ramping up production of the adapters that they're providing initially to Ford and to Rivian. Tesla also, there was also a recall on at least some of those Tesla adapters. There was also a recall on some of the early Electron adapters, in both cases for some manufacturing issues. Those have since been addressed, but Ford is now shipping both Electron and Tesla adapters. I believe Rivian is still only shipping the Tesla-made adapters, and other manufacturers are slowly rolling out their shipments of adapters from various vendors to their existing EV customers, as well as bundling them in some cases with new EV sales. Let's see, question, where's GM in this process for Chevy vehicles? They have rolled out OTA updates for the vehicles so that they can charge from a supercharger, but you have to use the Tesla app to initiate the charging session and to have the payment information, because superchargers don't have card readers. It's much like what it was even before Ford was the first to deploy their updates earlier this year, as it was last year when Tesla started rolling out Magic Docks. If you have to, you go and you plug in, you can use the Tesla app to have your payment information in there and then initiate and manage the charging session. Let's see. Yeah, okay. Next slide, please. So what we've also seen this year, I just mentioned the Magic Dock, which started rolling out last year on Tesla supercharger stations in a very limited basis. This added an adapter capability on the supercharger dispensers, so that if you are charging a CCS-equipped vehicle, you can, when you push in the handle on the Tesla charging cable and hold the button, it will release an adapter that locks onto the Tesla cable, and that's a CCS adapter. That is essentially the same adapter that they've been shipping to OEMs. And then earlier this year, Tesla or ChargePoint announced essentially what is the opposite of the Magic Dock, which is a CCS to J3400 adapter that they call the Omniport. The Omniport system basically takes a CCS cable, puts a CCS to J3400 adapter on it, works in much the same fashion as the Magic Dock, and is available to ChargePoint charger operators or owners to retrofit onto most of the existing ChargePoint dispensers, and it's also available, I believe, for their home chargers as well. And so this way, if the chargers can be used with either J3400 or CCS equipped vehicles. Next slide, please. Along the lines of the continuing progress, recently Iona, which is the joint venture of 8 OEMs, broke ground on their first charging station. They have plans to deploy 30,000 chargers by the end of the decade. This first one that they're branding as a rechargery is in Apex, North Carolina, near Iona's headquarters. It'll feature 10 bays with both CCS and J3400 cables. And this is what we expect to see going forward for most new chargers, is that much like what we've had for the past decade with chargers having both a CCS and a CHAdeMO cable on there, or at least some of the dispensers at charging stations having a CHAdeMO connector in addition to a CCS connector. Customers can pull up and use either cable and plug it into their vehicle as needed. Iona's chargers will have both J3400 and CCS cables on them. These are 800 volt, 400 kilowatt chargers. The stations are designed to be more appealing to customers, having a lounge, restrooms, food and beverage, and Wi-Fi, so that they can have something to do while they're waiting for their vehicle to charge. They also announced a partnership with Sheetz, which is a major chain of fuel stations, to put rechargeries at least 50 Sheetz locations, with 3 of those scheduled to open up before the end of this year. Next slide. We're now finally starting to see the first new non-Tesla vehicles being produced with a J3400 port native on there rather than a CCS port. Among the first ones are the Kia EV6 and Hyundai Ioniq 5 that are being built here in the US at Kia's new factory near Savannah, Georgia. I actually spotted a couple of these vehicles. I live not far from Hyundai's Tech Center here near Ann Arbor, and I spotted a couple of these in July being tested at my local supercharger station, and noticed that they had native J3400 ports on them. That was later publicly announced by Hyundai and Kia. And in addition, Hyundai Motor Group is going to be rolling out additional EVs built in North America next year, including the new Ioniq 9, as well as the Kia EV9, that will all have native J3400 ports. And Lucid, just a couple of weeks ago, started production of their new Gravity SUV, which also has a native J3400 port. Rivian has promised J3400 ports on their new R2 and R3 models. And what we'll probably see over the next year or two is as various EV models go through either mid-cycle updates or generational refreshes or new models being introduced beginning sometime in 2025, they will gradually transition over to using J3400 ports native on the vehicle rather than CCS. Next, I think that might be the last one. Yeah, this is what I was just saying. Other OEMs will probably be switching later in 2025, most likely for model year 2026 vehicles. As I mentioned earlier, most of the OEMs are still not including plug-in charge support. So for customers that want to charge from a Tesla supercharger, even if they have a J3400 port or an adapter, they will have to use the Tesla app, which is a little less convenient than just plugging in and charging the way either a Tesla, a Ford, or a Rivian vehicle can currently. But probably by the end of 2026, we'll probably see most new EVs being built with J3400 ports in them. And one other detail is that only version 3 and later superchargers are being supported by this effort. Version 2 superchargers, of which there are still quite a few out there, including one on the other side of Ann Arbor here, are not being supported by these updates to allow non-Tesla vehicles to charge. And I think that is it. Yep. All right. Thank you very much. And I'll hand it off to the next speaker.
Hey, this is Joan from Argonne. So I'm here to talk about the market, the current market, the sales, the registration, and the charging power. So so right now there's in last year, 2023, sorry, there was over 1.4 million plug-in electric vehicles sold in the US, and that includes both the battery electric vehicle and the plug-in hybrid electric vehicles. And this year, I think the sales right now currently updated to November is about 1.4 million already, and the sales expected to exceed last year's sales value when we close to the end of December. And as you can see that in some years that back in 2019 and 2020, Tesla actually count 60% of the market for the new vehicle come to the market. And currently only Tesla vehicle can use a J3400 charger without adapter, without magic dock. And that number actually reduced in the recent years. In 2024, updated to November, the Tesla counted about 40% of the share. So still is a big portion of the market, but that's decreased from the 60% back in the earlier years. And look at the registration, which is the vehicle on the road. So after 10 years of market development, there's over 5.6 million plug-in electric vehicles adopted in the United States. And you can see that how they spread over the states, different states. And California definitely has the highest EV adoption, and followed by some other states. So in average in the US, the percentage of the vehicles on the road, 2% of them are electric vehicles. So either battery electric vehicles or plug-in electric vehicles. So which means for every 100 vehicles you saw on the road, 2 of them are EV. And that number is 5 for California, which means that 5 out of 100 vehicles you saw in that state, actually 5 of them are electric vehicles. And the new vehicle sales in California also, new electric vehicle sales in California also is higher than other states. But in the last months, there were news claiming that Colorado actually is catching up in terms of the new electric vehicle sales and adoption. And there's more Northeast people in the seminar that you can see that New York, New Jersey also have a very high adoption. Interesting to point out is even Texas and Florida has a higher number of EV registration. The market share there is just a national average. That 2 states is just they have a lot of vehicles on the road. Next slide, please. So about 45 of the plug-in electric vehicles on the road in the US. So basically that's the current Tesla vehicles on the road in the US can use a J3400 chargers without adapter. So one thing to point out is J3400 does include both AC and DC. So they use the same pin for AC and DC charging. So that the dark blue part of the pie, that's basically for all the vehicles that are currently driving on the road. 45 of them could use that J3400 without adapter. That purple part, that basically the level 2 charging, that is the plug-in electric vehicle, plug-in hybrid electric vehicle. So PHEV, they mainly just use level 2. And several vehicle manufacturers has announced adopting the J3400 connector as early as 2025. And I think Sam gave a very good overview of which OEM already started giving out adapters and which OEMs are going to roll out the new vehicle models that can charge at the J3400 chargers. So going forward, we will keep tracking how many vehicles that are sold and also driving on the road could use the J3400. And we expect that the dark blue part of the pie will keep growing. And next slide, please. Yeah. So we talk about a lot of the charging station and also the charger power. So the current version of a Tesla supercharger can deliver up to 250 kilowatt of power, but that is not the maximum the J3400 connection is capable of. But on the other hand, how much the EV can accept, that is also depends on the vehicle make and model and their technology. So looking at our trend over the last 10 to 14 years, from 2010 to 2024, as you can see that in overall, the battery electric vehicle, which is the orange line, the sales weighted average maximum charging power that actually is increasing. So not only the Tesla, which is the blue line, that the acceptable charging power by the vehicle itself, no matter what charger you put them in, the vehicle has their acceptable charging, maximum charging power. So Tesla is keep increasing, but also the non-Tesla models has been also increasing in terms of their technology, which means they can accept a higher power over the years. However, there's no significant change since 2022. As you can see that after 2022, the line is kind of flat. But for both Tesla models and non-Tesla models, that you can see the technology seems stay at a constant level, which means the maximum acceptable charging power for Tesla is about close to 250, and for non-Tesla models is about 150 kilowatts. I think that's my last slide, and with that, I will transfer to the next speaker.
Great, thanks, Joanne. I'm Abby Brown with NREL, and today I'll be providing an overview of the alternative fueling station locator, explain the current connector landscape, and provide a breakdown of the J3400 connector by network. Next slide. So just for some quick background, the Department of Energy's Alternative Fuels Data Center provides information on data and tools to help fleets and fuel providers and policymakers make informed decisions with their energy goals. So I'll be discussing the data included in the Alternative Fuel Station Locator, and this is the most heavily used tool on the AFDC. Station Locator provides information and additional fuel data on alternative fueling stations in the US and Canada, and includes information on all of the alternative fuels, but of course today we'll be focusing on EV charging infrastructure. Next slide. So quick summary on how the database is updated. So NREL and our data collection partner, ICF, work closely to collect and confirm the station locator data. We contact every station at least once a year, make sure it's still operational and get additional fuel information. And then if the station is not operational, we remove it from the database. The biggest note for EV charging is that we contact several hundred industry contacts, and then also we have our direct lines to about 22 EV charging networks via their application programming interfaces or APIs. And through these APIs, we receive updates from them on a daily basis. So if a new station comes online or goes offline, the station locator is updated with that information on the same day. We also receive regular updates manually from about 47 other networks, and that includes Tesla supercharging and destination networks. Next slide. So a little bit about the connector type trends for the past 4 years, so since 2020. This chart is taken from the latest EV charging infrastructure trends report from the station locator, which are all available on the AFDC. And these reports provide snapshots of the state of the EV charging infrastructure in the United States using data from the station locator. Note that this chart on this slide is displaying the connector count, not the charging port count. And I also wanted to note that because these reports are written after the quarter ends, the reports lag a little bit behind the current day, but we're happy to share preliminary data at any time and are also happy to share the raw data from these charts if it's ever of interest. So over the last 4 quarters, the CCS connector type grew the largest, so 14.7% in Q2 of 24, followed closely by the J3400 connector type, which was a 4.6% growth in Q2 of 24. And preliminary data from Q3 shows that the CCS connector type grew by 8.4% and J3400 grew by 6.7%. So we are starting to see a trend of faster J3400 growth in the station locator. Next slide. So this slide breaks down the current connector type counts in the station locator as of yesterday, so December 16th, 2024. Out of these 154,500 ports, those are level 2, and roughly 7% of them are charging ports offered the J3400 connector type. And out of the about 51,000 DC fast charging ports, about 58% of those are offering the J3400 connector. Next slide. So I wanted to break down the current data we have in the station locator as far as which networks are offering J3400. So this pie chart is a breakdown of the number of DC fast ports on each network that have the J34 connector available and their percent of the total J3400 ports. We excluded Tesla from that pie chart on the left just because they are all J3400, so just wanted to show the scale there. But the table on the right does include Tesla and breaks down further and shows how many ports have those connectors. So about 1,284 ports have both the J3400 connector and the CCS connector. The majority of those are Tesla superchargers, so like the Magic Dock, and then followed behind by ChargePoint. And just a few other notes, because I saw some questions in the chat. As far as NEVI station goes, 32 Tesla supercharger ports have received NEVI funding and only have the J3400 connector available. But there are also at least 6 NEVI funded station locations that have both the J3400 and CCS. If you ever want details on those specific stations, we can get those for you. So just reach out and we can give you the specific information. And then as far as adapters go, I just wanted to make a note that if a station has an adapter available, but it's not, a part of the station hardware, we do not capture that information in the station locator. So just to note that adapters are not included in these counts. And next slide. Just a quick information on the different links that I mentioned, the station locator, and then the landing page for all of the charging trends reports and our contact information if you need to reach out about any questions. I think that's it.
Great. Thanks so much, Abby. And to the rest of our panelists, really appreciate it. We do have a little bit of time for questions. And I did want to note that today's recording and slides will be posted on driveelectric.gov. So you will be able to access this afterwards. If you don't get your question answered today, you can follow up with us at driveelectric.gov/contact and submit your question there, and we'll make sure to get back to you. So I think the first question maybe is for Frank and Sarah. There's been some chatter in the Q&A about the standardization of J3400 and how it is now a recommended practice, I believe. Can you just tell us, like, what does this mean? Is it now available for any manufacturer to make or to deploy on charging infrastructure? Is it pretty much ready to go?
Yeah, so the technical information report, which is the step before the final standard is voted on, was out in September. It is available and to anybody who wants to come and get it on the SAE website. And then there are a couple of other processes in the standardization process. There's voting and so forth, but the bulk of the group's work, the bulk of the technical committee's work is encapsulated in that technical information report, which was published on September 29th, 2024. So it's a great resource that's available now.
And I'll add to that a little bit. I was answering questions in the Q&A as we went along. So standards are living documents. And one of the things that's really unique, like the lightning in the bottle we have with this, is that the standardization process, so they're living documents, right? And they go through phases. They go through the TIR and then the recommended practice and then the full standard, and they get updated as they go. Some standards are only live in one geography. Some of them are harmonized with one other country. Some of them are tri-harmonized standards. So standards live and breathe in different ways, but they should always be updated. And one of the things about J3400 that makes it so unique is that the way it's living and breathing is that it's going in a more parallelized fashion with engineering innovation. So its updated process kind of went with the development of engineering, and it went in a really rapid way while we were iterating on the engineering itself. One of the things that the joint office, so to Frank's point, we kind of pushed a little bit SAE in the private sector, and we're like, hey, we'd like to see this move into the public good and become an open standard. And concurrent to that, we want to benchmark it. We want to take it to Testables, one of the largest kind of open testing events that there are. They happen in North America, they happen abroad. So we want to benchmark it at the same time. We want to do a horizontal across all the suppliers, all the manufacturers out there, get a benchmark test, take some of those test results, feed them into the standardization process as it moves into RP, feed it into engineering updates that go right onto the charging controllers, right into deployment, and then they're all kind of working together. So we've learned something through this J3400 process. So not only is it's not just that it's now ready to go starting in October, right? They've been deploying this for years. Tesla's been on this for years and years, and other manufacturers have been working on this in more of a test and development environment. Probably, we don't know, but probably for quite some time, several years. And it's just now hitting the public stage, but it's all working together, and it's moved now into a production environment, but this has been in production for quite some time. But now that we're doing it all together, we can develop as across, all of the suppliers now that we moved it into the public good, and we can iterate and develop faster and faster and faster. And that's kind of the thing that's unique about this J3400 standard. So it's been ready for a while, but moving it now into a public good helps us move at a more rapid pace.
Great, thank you. And then Sam, I think I've got a follow-up question for you. Just a few questions asking you to reiterate the whole point about non-Tesla vehicles charging at older Tesla stations. Was that for just plug and charge, or was that kind of universal? Like if you have a non-Tesla vehicle, can you not charge at some of the older stations?
Yeah, older stations that have the version 2 superchargers will not support non-Tesla vehicles. So for example, here in Ann Arbor, there's 2 supercharger stations. One is an older one, is one of the first in Michigan, has version 2 chargers. That one does not work even with an adapter. Whereas newer, anything that's version 3 or the newer version 4 chargers will work with an adapter, or if you have a vehicle that has the native port. And something I put into the chat that I just wanted to correct an error in my talk earlier. GM vehicles don't have to use the Tesla app. They don't have plug and charge capability, but you can also use the GM app, which in addition to the superchargers also gives you access to 178,000 chargers in all. So you can either use the GM app or the Tesla app on GM vehicles.
Got it. And I think we just have time for one more quick question here. But do you know, is there any effort across the industry to establish the best practice for the port location on the vehicle?
I think there's discussions. I don't think anybody has agreed on anything yet. Even at Hyundai and Kia, for example, on their model year 25 models, Kia on the EV6 actually did move the port over to the driver's side rear corner because it was easier for them because there's a plastic valance there, so it was less tooling. Hyundai kept it on the passenger side because they didn't have to change the steel stamping. I suspect that over time we'll probably see the ports probably start to move towards that, either the left rear or the front right corner, diagonally opposite.
Super. Well, I want to thank all of our panelists today. Really appreciate it. And again, I know there are some outstanding questions that we didn't get to answer, but you can follow up with us here at the Joint Office and we'll get those for you. If you could just advance to the final slides, please, and we'll go ahead and wrap up. So we do have useful resources on driveelectric.gov. The NEVI FAQ that Soraya and Will highlighted is available on driveelectric.gov. We've also got a link to the station locator that Abby featured. There's some really great ChargeX reports. So ChargeX is a multi-lab consortium that focuses on addressing charger reliability issues and consumer experience. And so there's some recommended actions to improve adapter safety. I know we talked a lot about adapters today and just want to highlight that specific report. And then some of the work that Joanne highlighted on EV sales, that's also available on driveelectric.gov, where we highlight the light-duty electric vehicles monthly sales data. And then, of course, ongoing funding opportunities and work that the Joint Office is doing. Next slide, please. So really appreciate everyone joining us today. Thank you very much to our panelists. Please, again, do follow up with us if there's something that you'd like to learn more about that we weren't able to get to today. And then also consider subscribing to our newsletter. So when this webinar is posted on driveelectric.gov, with the recording, we will highlight that in our biweekly newsletter. And so that's a great way to stay abreast of information coming out of the Joint Office. So with that, thank you very much, everyone. Really appreciate your time and look forward to our next conversation.